Hey everybody, this is Larry. This is me trying to do the last weekly premium problem or whatever it's called in April 1538. Guess the majority in a hidden array. Alright, so we have an integer array nums where all the integers are nums 0 and 1. You will not be given direct access to the array. Instead, you have API, which has the following functions. You have query, where you're given 4 ABCD, and then you're just giving the distribution. Okay. Uh, uh, hmm. So you don't really. What? Man, this is hard to read, so I'm reading it again. Okay, so 4 if they're all the same, which is fine, I guess. 2 if 3 elements is equal to 0, and 1 element is equal to 1 or vice versa. Man, why don't they just name it like 4 and 3 or something? I guess it's the delta of 2, but still. And then 0 is if they're equal. Okay, so maybe that's just a delta, but it's still very confusing. Okay, fine. What do we return? Return any index of the most frequent. That's what I was trying to say. Okay, that makes it a little bit better. Because I was trying to say, like, you never really get to know whether any number is 0 or 1, so it's a little bit hard to figure out. But okay, so you're able to make at most 2 end queries, and you're trying to get at least an index of the most amount, right? Whenever I see majority, my inclination is to think about, what's it called, Freud's majority algorithm or something like this. Did I make that up? No. Boiler-Moore. I think I just confused the names. Boiler-Moore majority algorithm, right? And that one is basically, yeah. So for these kind of discovery problems, I mean, very often it's binary search, but I don't know that this is binary search. You have to look at each element at least once, probably, in some way. But then what, right? So ground truth. The other thing is that you have to do is just make an observation or make a statement or make a query that once you find something that's true, you could build off that, right? I'm taking a look here, and n is equal to 5, so n could be any number. Okay, so it's not like any particular realness. Okay, and okay, fine. What's the minimum number of cores to find a majority algorithm? Yeah. And and these things are very exploratory. You don't always know necessarily, what to do, to be honest. Yeah, one idea I have is that if so you have 5 elements, right? Which is a little bit awkward, to be honest. All right, let's start with 5 elements. I was going to say for 6 elements. No, I guess for 7 and up, by pigeonhole you need, or like 4 will appear for some answer, but I don't know that that's good enough, right? I think one thing that I would think about trying is, okay, I mean, the first query, there really is no differentiation, right? Like you have no information. So the first query, let's just say, is always going to be the first 4 elements in the cell, right? In that case, if they're the same, let's say we have 5 elements, right? If 4 of the elements are the same, then what happens? Well, then that's one of the answer, really. There's no other way of doing it. But yeah, these problems are very hard constructive for me anyway. Let's say we have 0. What does that mean? That, and you know, for me, I always have to play around with numbers, right? So let's say you have 0011 is your first 4 numbers, and then it's hard because basically, let's say you know you remove this number and then added a 1. You know, let's say you have 5 numbers, so you have to, you know, that means that it's still going to be 0, which means that these 2 numbers are the same. Right? I mean, here it also means that one of these 2 numbers are the majority, because you know that in all permutations, it means that for 5 elements anyway, right? But I don't know. But like, I don't know how to generalize it from that is my point. And then let's say it's a 0. Then now you go from 0 to 2. So that means that these 2 numbers are not the same. And if these 2 numbers are not the same, is there a ground truth? I mean, I think that's it, right? Maybe. Or in this case, maybe that's it, because then now if these 2 numbers are not the same, you could use these 2 to kind of maybe differentiate 2 other numbers, right? To determine whether those 2 other numbers are the same or not. But then and then you could kind of do a lot of logic that way, though it's very annoying to get right, to be honest. That's why I'm like not really happy about it. We'll have to see. But then now let's say your first 4 numbers are, you know, something like this, so you're giving it 2. How do you get, like, let's say you have let's say you take the first 2 numbers or first 3 numbers, because you don't know what they are, so without loss of generality, and then now you see a 1. Well, I guess you still get a 2, so it's the same number. And if it's 0, then you get 0 or something like this. So I guess in that sense, if you take, if given 5 numbers, if you take, let's just say you have, I don't know, A is equal to reader dot, what is the reader dot query? 0, 1, 2, 3, 4, or 1, 2, 3, and just say code Q1, and then Q2 is equal to reader dot query of 0, 1, 2, 4, right? And then basically if Q1 is equal to Q2, then index 3 and 4 are the same, else index 3 and 4 are different. Okay. I mean, so this is something that we built, made an observation on, right? Now, how do we generalize it? So these 2, I think it's fine, because we had 2 times n queries. We have plenty of queries. What can we say? If these 2 are the same, then we can use these 2 . Trying to wrap my head around it, to be honest. if these two are the same, then can we use these two to build other things, right? Is what I'm trying to figure out. But either way, it's like super complicated. Okay. I mean, I think I'm just doing 3 and 4, but I guess now we can generalize it, right? Meaning that we could generalize this to I, and then now we're checking whether every number is equal to 3 or 4. So, okay. So if 3 and 4 are the same, that's fine. Then we do a count. Oh, jeez. Okay, so okay, so maybe I do something like this, right? So now say Q1 is equal to 0, 1, 2, and 3, and then now we have for I in range of 4 to n. How do you get n? Oh, length. Okay, so n is equal to reader.length, right? And then now let's just say Q2 is equal to this. If Q1 is equal to Q2, then let's say same is equal to 0, different is equal to 0. We just same else different is 1, right? Okay, and this is I say. Okay, right? So now we looked at every number after 0, 1, and 2. And then we have 3, right? So then now this is kind of tricky for small n's, I think. But basically now we have to just count 0, 1s, and 2s, right? So that's the annoying part, maybe. Okay, right. So then now maybe Q1 is equal to reader.query of, I don't know, 1, 2, 1, 2, 3, 4, right? And then now, so basically we have, so now if we check this, no, that's not right. We want to check whether 0 is equal to 3, right? So then now we do this, and then we Q2 is equal to reader.query 0, 1, 2, 4, right? Something like this, maybe. This is kind of awkward though, the way I'm doing it, but maybe I'm not generalizing it enough quite yet. Because basically now we're comparing 0 and 3. Also, if we find a different number, we should have a different index is equal to none. If this is different, then if diff index is none, diff index is equal to I, just so that we know the same. Because for same we return 3, for difference we return different index, right? Okay, I guess we just do it manually, right? For now, I'm gonna do that. Maybe I could come up with a slightly cleaner way, but I'm just gonna do it manually for now. So 0, 2, 3, 4, right? Q2 is equal to reader dot query. 0, 1, 2, 4, and then same thing, right? I could probably put this in a slight helper, but all right. But for now, I'm just gonna copy and paste. You could optimize this, but I really want to focus on correctness first. And in this case, correctness is a lot of copy and paste, perhaps. So compare 2 and 3, right? So 1, 2, and then 1. Yeah, okay. Actually, that works out. Yeah, and we already compared 4, so that's fine. Same is greater than difference, then we return 3. Else, if same is less than difference, return diff index, and then else return -1, right? Okay, so we're good here on the first 2 at least, but not this one. I return 4 when it returns -1. All right, let's take a look. It may be that I am off by 1. That is exactly right. I'm off by 1 because I don't. Well, same is always going to be 3. Same is the same as 3. So I think that's why. If that makes sense. Because I don't count the value in the third index because I just kind of compare with everything else. All right, let's give it a submit. Oh no! Oh, I returned none. Why did I return none? All right, let's. Why did I return none? I mean, this should return. Oh, because diff index. Oh, I see. Because this, yeah, the small case is weird. Okay, fine. Okay, so I guess I just have to do these here. It's not really a big deal, but then I didn't do it. That's what happens with copy and paste, though. This makes things like much more annoying, right? But nothing insurmountable. Just gotta do it. Give it a submit. All right, there we go. I mean, a little bit of a silly mistake because I kind of forgot. But this is a mess for this part, but it's okay. We could probably refactor this. Let me actually do refactor this because this is kind of fugly. But yeah. Okay, so then now for I in range of from 0 to 3, non-inclusive, find diff or something like this, right? Maybe diff I, right? And then maybe my helper function is still a little bit awkward, but yeah. And then now we have list of range to 5. We remove X. And the other one we removed 3, right? I guess this is always 0, 1, 2, 4. I guess I missed that part. So then we can actually, okay, fine. So Q1 is equal to this thing. Reader dot query, right? And then actually Q2 is equal to reader dot query 0, 1, 2, 4. I actually didn't see that earlier, but so okay. And then now right. And oh, and also I guess I have to do non-local on this side. Right. And now this should be better, maybe. Okay, maybe not. I don't even do this to make it okay, fine. I guess that part is. I thought I could convert it into where arcs, but I guess not. Okay, fine. Oops. Where did it go? Oh. Oh, just remove not. Is it delete or something? Don't remember my Python. I don't usually use ugly Python like this, that's why. But okay, so now this is good. Maybe that was the issue. Oh, it was. Okay, so I thought that part, maybe I just confused a little bit of things in my head. And you could rewrite this in a certain way anyway. But yeah, but that's basically it. So then now, essentially, we do only n queries, right? Maybe n plus 1. And technically, this query, we already have it done. Because we use it once here, but so if we're lazy, we can actually cache, or if we're not lazy, we can actually cache it, and then we use exactly n queries. Is it true? Yeah, I think we use exactly n queries then, right? Because, or maybe n plus 1. I didn't really count it, but yeah. Okay, cool. That's all I have for this one. Let me show you the top and the bottom. But the idea is just to kind of figure out what the same and the difference, and then just kind of count them all up. So yeah. Cool. Kind of a tricky one for sure. I think it's just about try to figure out what's different or what the invariants are and the queries and you know, yeah. That's all I have with this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.